Okay, in this video we're going to look at how to evaluate trigonometric integrals that involve powers of tangent and secant. So these are the examples that we are going to work through. This video is building upon part 1 and part 2 of this series, whereby we looked at how to evaluate integrals involving powers of sine and cosine. You may find it helpful to start by having a look at those ones before you continue this one. So I want to start by setting up some simple guidelines on how to evaluate these integrals. Okay, so first of all, the identity that connects secant and tangent is this one here, and then the derivative of tangent is secant squared, while the derivative of secant is secant tangent. Now, in terms of the methods or the guidelines of integrating these, mainly we'll be looking at whether we can save a secant squared. If we can, then we look to write everything in terms of tangent. If we can save a secant tangent, then we look to write everything in terms of secant. Right, so the integrals that we're going to look at of the following general form. All right, so we have got integrals that are just powers of tangent or powers of secant, or a product of powers of tangent and secant. So if this power of secant or that power of secant is even, then we save secant squared and write everything in terms of tangent. So just like I said, because we know derivative of tangent, secant squared. Then if P is odd in this setup, then we save a secant tangent and express everything in terms of secant. Again, that's because derivative of secant is secant tangent. And then if n is odd, where it's bigger than 1, so for this type of integrals we just use integration by parts. Lastly, if p is even and q is odd, we write everything in terms of secant. So if p is even, q is odd, we just write everything in terms of secant and then use the methods we've talked about for evaluating those ones. All right, so in our examples, we're first going to start with the powers of tangent, power 1, here, power 2, power 3, then secant to the power 1, we skip secant to the power 2, I'll tell you why. Then here we look at cotangent. Yeah, actually before we go to the examples, it's worth noting that while our focus is going to be on secant and tangent here, these ideas can be used equally to integrate powers of cosecant and cotangent. That is because cotangent and cosecant satisfy properties that are very similar to the properties satisfied by secant and tangent. So for instance, 1 plus cot squared is cosecant squared. Derivative of cot squared is negative cosecant squared, similarly to this one. And then derivative of cosecant is equal to the negative of cosecant theta cot theta, which is similar to this one. So that's why we have got an example here involving cot and cosecant, just to demonstrate that point. So let's start with the first one then, which is the integral of tangent. So for the integral of tangent, we are going to write this in terms of sine and cosine, and then we're going to use the ideas we talked about in parts 1 and 2. So that's why it's advice to make sure you have seen those ones is useful here. So we're going to let u be equal to cosine theta, because then du is negative sine theta d theta. Sine theta d theta we have in our integral. So from that it tells us that sine theta d theta is negative du. So we can write entirely in terms of u. It's going to be the negative of du over u. So this is going to be the negative of ln magnitude of u plus c. However, u is cosine, so that's going to be negative ln magnitude of ln, negative ln of magnitude of cosine theta plus c. This we can write as ln of secant theta if we absorb that negative into the ln. So this is a standard result that you might want to memorize. So integral of tangent theta is equal to ln of secant. Okay, then in B we have got tangent squared theta. So this one we simply rewrite it in terms of secant. So it's going to be secant squared theta minus 1. Now derivative of tangent is secant squared, so integral of secant squared is simply tangent. So this thing is going to be tangent theta. Integral of 1 is going to be theta plus c, and so that one is sorted out. In C we have got the integral of tangent theta cubed. Okay, so this one we're going to split it into two. We're going to write it as tangent theta times tangent squared theta. Then tangent squared theta we're going to write using secant, so secant squared theta minus 1. Then we're going to write this as two integrals. So tangent theta times secant squared theta d theta minus integral of tangent theta d theta. This one we have just worked out in part A. This one we have got secant squared here, which we know is the derivative of tangent. So for this one, simply going to let u be equal to tangent theta, then du going to be secant squared theta d theta. So this bit is just going to be du. So if we let this be I for integral, then our integral is going to be integral of u du minus integral of tan is secant ln of secant theta, as we just said. And so this one is going to be u squared over 2 minus ln of magnitude of secant. So u, remember, is tangent, so that's going to be 1/2 tangent squared minus ln of magnitude of secant. So that sorts out part C. Then part D is the integral of secant. So this is yet another standard integral that after this you will want to memorize. So integral of secant theta. The way we integrate this, again, this is a standard method. We multiply this by secant theta plus tangent theta over secant theta plus tangent theta. And then the numerator is going to be secant squared theta times secant theta tangent theta over secant theta plus tangent theta. Now notice that the derivative of tangent is secant squared. Derivative of secant is secant tangent. So what we are going to do here is we're going to let u be equal to the denominator secant theta plus tangent theta, then du is going to be secant theta tangent theta plus secant squared theta d theta, which is simply the numerator. And so our integral is just going to be the integral of du on u. So this is going to be ln of magnitude of u plus c. So that's ln of secant theta plus tangent theta. So again, this is another standard integral that you will want to memorize. In future, we are just going to use it without deriving. Okay, then so that is secant to the power 1. Secant to the power 2 integral of that, we've just commented that it's just tangent. So what we're going to do is, in the next question in E, we're going to look at secant cubed. Okay, so in E we're going to look at secant cubed. However, maybe we will do that in part 4 of this series. Otherwise, thank you for watching. Hopefully these are useful. Please do remember to subscribe to support this channel and like the video. So we're going to continue with example number E in the next part of the video, which is going to be part 4.